Here we are going to see the question from control systems given in GATE 2013. Given that the open loop transfer function of a DC motor is given as W of S divided by VA of S equals to 10 by 1 plus 10S when connected in feedback as shown below. The approximate value of Ka that will produce the time constant of the closed loop system by 100 times as compared to that of the open loop system is. Now we are going to find the Ka value that will reduce the time constant of the closed loop system by 100 times as compared to that of open loop system is. Now we'll see the solution for this. So here, coming to the solution, given that the open loop transfer function given that the open loop transfer function is W of S divided by VA of S is given as 10 by 1 plus 10S is given. So here, by observing this is equals to, from this we can find the time constant. From this, the time constant of this open loop transfer function is obtained as, we know that 1 plus that characteristic equation is the denominator is equals to 1 plus TS, that is given as 1 plus 10S here. So from this we can write that T equals to 10, the time constant is equals to 10. This is nothing but the open loop time constant. So in the question it is given that the value the time constant of the closed loop system by 100 times as compared to that of open loop system. So here we have the open loop time constant, then given that the closed loop time constant represented with the T dash is equals to T by 100 here. That is nothing but we already calculated the T value, that is 10 by 100, that is 1 by 10 is the closed loop transfer closed loop time constant. Then we need to find the Ka. To produce this time constant of 1 by 10. So now we are going to find the closed loop transfer function. That is obtained by calculating the closed loop transfer function here Ka, and this open loop transfer function 10 by 1 plus 10s are in cascade, so the multiplication will get, and we have a unity feedback here, unity negative feedback. So using that applying the open loop transfer function, closed loop with the unit negative feedback, we will get the total transfer function of the closed loop is, then the closed loop transfer function is equals to, we will get this as the W of S divided by R of S. The output is W of S and the input is R of S. So here we have open loop transfer function Ka into 10 divided by 1 plus 10S. We have the expression having that the closed loop transfer function G with feedback of H, with a negative feedback of H. Then this is simplified as this is output C of S and this is R of S. Then we'll get that C of S divided by R of S equals to 1 by, this is G by 1 plus GH. So by applying this expression here, by applying this expression, this is G divided by 1 plus GS, that is GH, that is KA 10 divided by 1 plus 10S into H value is given as 1 here. So by simplifying this, we'll get this as KA 10 divided by 1 plus 10S plus 10 KA will get. So by simplifying, we are getting like in the form of 1 plus ST in the denominator, 1 plus ST in the denominator. So taking this 1 plus 10 KA as common, we'll get this as 10 KA divided by 1 plus 10 KA as common. Taking this as common, this becomes 1 plus 10S divided by 1 plus 10 KA. Then this is equals to 1 plus ST form, then the T dash here, this ST dash, this is equals to 1 by 1 plus ST dash form. So the T dash value is equals to, it becomes T dash. We already know that this is equals to 1 by 10. So in place of this T dash, we have 10 by 1 plus 10 KA. Then by simplifying this, we'll get that KA equals to 9.9 we'll get. This is approximately equals to 10, that is given in the options. That is option C is the correct answer. So the simply will find the open loop time constant, and given that condition, the closed loop time constant is 1 by 100 times then open loop time constant. Depending on that, we will find the KA value.